Welcome back, class. So in this video, we're just going to do an application problem of our inverse derivative function derivatives. So here's the question we're going to do. We're going to find the indicated point on the graph of f of x equals x minus 2 times the arctangent of x. And like magic, I love this thing, there is the graph of x minus 2 times the arctangent of x. And so before we just dive into doing things, we should probably make sure we understand what's special about this point that I have indicated on the graph. And the thing that's special about this point is, again, I'll give you a minute to think about it. Right, it's again the fact that this is a place where the tangent line is horizontal, which you'll see is a recurring theme throughout this course. It's come up in a bunch of different contexts, but that's what's special about this point. So I've got to figure out where this derivative is going to be 0. Okay, so, well, I can't do anything until I have a derivative. So let's go ahead and take f prime of x. So it is going to be 1 minus, and then this 2 arctangent of x, its derivative is going to be 2 times 1 over 1 plus x squared. So I'll rewrite this as, and so I want to make a common denominator here. So I'm going to write this as 1 plus x squared over 1 plus x squared. That's my 1, minus 2 divided by 1 plus x squared. And so this is going to be x squared minus 1 divided by 1 plus x squared. That's going to be our derivative. Okay, so what are we then going to do? Well, we want to know when this is 0. And so we have to remember, always, that when we're trying to figure out where a fraction is 0, we're always looking only at the numerator. We're looking for where the numerator is 0. We don't care about the denominator basically at all. So we'll do that. We'll take x squared minus 1. We'll set that equal to 0. That'll familiarly give us x squared equals 1, which will give us x equals plus or minus 1. Okay, so there are 2 such points in all of existence. And which one is this one? Well, you'll notice pretty visibly that the x-coordinate of the point we're looking at is negative. So it must be the case that the one we're looking for is x equals minus 1. Which means, and apologies for doing this, but I don't want to destroy too many trees here, we're going to have a point where the x-coordinate is going to be minus 1, and then the y-coordinate here is going to be f of minus 1. Okay, what's f of minus 1? Well, it is minus 1 minus twice the arctangent of minus 1. Okay. And so what's the arctangent of minus 1? We can hide this for a second, pull up our unit circle. We're looking for a place between minus pi over 2 and pi over 2, where the tangent is minus 1. And that happens at 7 pi over 4, although remember we have to write it as negative pi over 4. We have to view it as going backwards pi over 4. So this quantity here, it is minus 1 minus 2 times minus pi over 4, okay, which is to say, at the end of the day, that this thing is pi over 2 minus 1. That is the y-coordinate of our point. Until next time, class.